Hello, pre-calculus student. This video is for chapter 6.3, inverse trig function. So we talks about how the trig function, the inverse trig function for sine, cosine, and tangent are looked up by from the unit circle using reverse lookup, where sine functions we would use quadrant 1 and 4 with the angle being relabeled as negative. If it's we don't usually use angle, so just the radian. And then for cosine, we don't need to relabel anything. It's 1 and 2. For cosine, inverse cosine, you look up starting from the x value of the value, and the angles are the output. For sine inverse, you look up y value as your input, and then the angles is your output. For tangent, you have to do some work because you have to know the ratio. So I am going to write the tangent ratio in like green, so it's help our lookup faster. So for y over x for tangent, I would just say tangent theta or tangent theta. What would the y over x be? This would be width 3. This would be 1, and this would be width 3 over 3. For this would be 0. For the tangent, this would be negative width 3 over 3. This is negative 1. For arctangent, this would be negative width 3. So that's the 6th value, and this is undefined. So this is because it's VA. For tangent, this is undefined. So it would help us to do the arctangent lookup. So first we would want to do arcsine of negative of 1/2. We used this as an example last time. So we look at, because of sine, we look at the y value, and in this particular y value, so if it is positive, you look at the first quadrant. If the value is negative, you look at the fourth quadrant. 1/2 is here, and the angle is pi over 6. So we write the angle is pi over 6. Sine inverse would negative with 3 over 2 because it's negative. So we know we should go up. We'll go here and look at the y value. This is negative with 2 over 2, and the angle is negative pi over 4. This is negative pi over 4. You know that for sine and tangent, if your input is negative, your angle is negative. For cosine, it's the other way around. This is not the case. So you need the x value to be negative with 3 over 2. So x value negative with 3 over 2. And then the output is 5 pi over 6. So don't look at 1 and 4. Look at the x value of negative with 3 over 2. It's 5 pi over 6. Arctangent 1. So because it's positive, we look at first quadrant. For tangent arc, this is the 1, and the output is pi over 4. Arctangent negative 1. So let's look at those 1 and negative 1 thing. In negative 1, it would be in the fourth quadrant, and I see the y value negative 1 here. It corresponds to negative pi over 2, right? It's undefined only for tangent. For the y value sine is still here. Tangent negative 1 would be on quadrant 4, negative 1 here. Your angle is negative pi over 4. Cosine negative 1 is the x value being negative. So it's in quadrant 2. So this is the x value negative 1. The angle is pi. So you reverse look up pi as the answer. And then cosine inverse 1/2 is a positive. And so we look at the x value, positive 1/2 here. The angle is pi over 3. Right? How come? Okay. So let's look at the using calculator to evaluate inverse trig functions. So check the appropriate mode for radian or degrees. So so if I want to do inverse, so this is always if you're just looking at a value. So this is the the outside. So you have to make sure that your answer is in rate. So this is the input, and you have to look at where your answer. So set the mode first. Set the mode for input, because otherwise they'll give you an angle. Okay, so let me go to the calculator. Oh, I don't have it open. So open a calculator. Turn it on. Clear this. Oh, okay. Quit first. Clear this. And then we click mode. And in my case, it's radian already, so I'm okay. So sine inverse is second sine, right? Second sine. So you see that sine inverse shows up. And then they wanted to do 0.97, so just the 0.97, 1.3252. This is the radian, so equal to 1.325. Is it 52 or 92? 252. And then cosine inverse, we want it to be in degrees, so sometimes you can. So we would go to the mode and set, we are doing this in degree, equate. Then you do second cosine, it will be the sine inverse, negative 0.4, negative 0.4, 113.6 degree. Remember to write degree. Okay, so this is how you do sine and cosine inverse using the calculator. If the input is not a special angle like 1, -1, 0, all those. Let's look at using the inverse trig function to find angles in the right triangle. So the inverse function is also useful if it is in the first quadrant to solve a right triangle. If you have two sides of an angle, you can two sides of a right triangle, you can find an angle in between. So for example, of course, your trick is SOHCAHTOA. SOHCAHTOA. Okay, so solve the angles and sides of the right triangle. So I have to solve this angle. Oh, they wanted to solve everything. So let's just give this. I don't know if it's longer. Okay, so let's say this is A, and then let's say this is angle. Um, let's label them because that'll be easier. A, B, C. Okay, so this will be side A, and this is angle B. So we need to solve all the angle A, angle B, and also sine A. Sine A is easy because you can use Pythagorean theorem, right? A square plus 9 square is equal to 12 square. So A square is equal to 12 square minus 9 square. Subtract first before you do the square root. It will be 144 minus 81. In the calculator, 144. 144 minus 81. That is equal to square root of 63. Square root of 63 is 9 and 7. So be 9 times 7. So be 3 root 7. Okay, so that is the size. What about angle? 3 root 7 actually you can do, yeah, for 63. For approximate value is 7.9. Okay. So it is the shorter side. And then we would need to do angle A, right? Angle A, you can see relative to angle A, 12 and 9 are hypotenuse and adjacent. Okay, H and A, ka. So you would say cosine of theta is equal to A, H, right? And then you would say, I need to find angle, so I do cosine inverse outside. You go to 9, cosine inverse 9. Okay. Cosine inverse 9 over 12. So cosine theta would equal, no, not cosine theta, it's theta, because they will cancel. Not very responsive. Theta would equal to cosine inverse. Put in your calculator. Make sure it's in degree mode. and then do cosine inverse. Second cosine, 9 over 12, that is equal to 41.4. So we solve angle A. What about angle B? Angle B will be 180 minus 90 minus 41.4. So that degree, they all in degree. So I can actually just do 90 minus 41.4, also faster, 48.6. That's it. Okay. Solve the size of the right triangle. So size and angle. So I have this, which is according to this angle, it is hypotenuse, but for this is O, right? So OH, what angles? What do I need to do? OH is sine. So let's do the angle first. I would write the angle, the ratio of sine theta equal to O and H. So sine inverse both sides. Sine and sine inverse cancel. Will be sine inverse this side. This cancel. So now I have theta. Theta is sine inverse 6 over 10. So we put in the second sine inverse 6 over 10. I got 36.9. Then angle, the other angle would be 90 degree minus, let's say this is angle B. Angle B would equal to 90 degree, because this two should be 90 degree, right? 36.9. You can also do it this way. 53.1. So I solved the other angle, and then with this missing side, let's say this is B. So we will have B squared plus 6 squared equal to 10 squared. B squared would equal to 10 squared minus 6 squared equal to B would equal to square root of 100 minus 36. Actually minus it is 64. Square root, that's equal to 8. We solve all the sides of a right triangle. So we would solve a what problem? Okay, a 20-foot ladder leans up against the sides of a building. So we have a building, and then there's a ladder supposed to be on the ground. So this is 20 feet. So the foot of the ladder is 10 feet away. So this is 10 feet away from the base. What is the angle of elevation to the top of the ladder? So if I want to look up the ladder, what would this angle be? Angle of elevation is about the angle to the horizontal, right? Theta. Okay, so let's do look at this. This is hypotenuse. This is adjacent, right? Car. So we use cosine. We would say cosine this theta, we don't know what it is, but is A over H 10 over 20. So cosine inverse of cosine theta would equal to cosine inverse 10 over 20. Cosine inverse and cosine, so it will be cosine inverse 10 over 20. Cosine inverse 10 over 20. I think it's a special angle, right? It's a 60 degree. But you can also get it from the calculator. So in the next video, we'll talk about composition of trig function and its inverse.